Not only do sysadmins in a small company work with users and computers, they also have to deal with printers and phones too. Whether your employees have cell phones or desk phones, their phone lines have to be set up. Printers are still used in companies, which means they have to be set up so employees can use them. Sysadmins might be responsible for making sure printers are working, or if renting a commercial printer, they have to make sure that someone can be on site to fix it. What if a company's fax machine isn't working? If you don't know what a fax machine is, that's not totally surprising. They've been slowly dying since the invention of email. Fax machines are still alive and kicking at companies, and they're a big pain to deal with. Sysadmins could be responsible for those too. Video audio conferencing machines. Yep, they'll probably need to handle those too. In an enterprise setting, sysadmins have to procure this hardware one way or another. Working with vendors or other businesses to buy hardware is a common practice. Setting up businesses accounts with vendors like Hewlett-Packard, Dell, Apple, etc. is usually beneficial since these companies can offer discounts to businesses. These are things that sysadmins have to think about. It's typically not scalable just to go out and purchase devices on Amazon, although if that's what's decided, they could do that too. Sysadmins must be sure to weigh their option before purchasing anything. They need to think about hardware supply. So, if a certain laptop model isn't used anymore, they need to think of a suitable backup that works with their organization. Price is also something to keep in mind. They will probably need formal approval from their manager or another leader to establish this relationship with a vendor. It's not just technical implementations of hardware that sysadmins have to consider. It's so many things. We talked about troubleshooting a lot in an earlier course, but it's worth mentioning again. When you're managing an entire IT infrastructure, you'll constantly have to troubleshoot problems and find solutions for your IT needs. This will probably take up most of your time as an IT support specialist. This could involve a single client machine from an employee or a server or service that isn't behaving normally. Some folks who start their careers in IT support deepen their knowledge to become system administrators. They go from working on one machine to multiple machines. For me, I made the leap during my internship as an IT support specialist in college at a semiconductor lab. The lab ended up closing and they needed help deprecating the environment. So what started as an IT help desk support quickly transitioned to a sysadmin role. That opportunity was my golden ticket to dabble into Active Directory, subnetting, and decision making, which is a core part of this job. Sysadmins also have to troubleshoot and prioritize issues at a larger scale. If a server that sysadmin managed stopped providing services to 1,000 users and one person had an issue about the printer, which do you think would have to be worked on first? Whatever the scenario, there are two skills that are critical to arriving at a good solution for your users. And we already covered them in an earlier course. Do you know what they are? The first is troubleshooting, asking questions. Isolating the problem, following the cookie crumbs, and reading logs are the best ways to figure out the issue. You might have to read logs from multiple machines or even for the entire network. We talked about centralized logging a little bit in the last course on operating systems and you. Becoming a power user. If you need a refresher to how centralized logging works, check out the supplemental reading. Anyway, the second super important skill that we covered is customer service. Showing empathy, using the right tone of voice, and dealing well with difficult situations. These skills are essential to all IT roles. In some companies, sysadmins have to be available around the clock. If a server or network goes down in the middle of the night, someone has to be available to get it working again. Don't worry, a sysadmin doesn't have to be awake and available 24/7. They can monitor their service and have it alert them in case of a problem. We'll discuss service monitoring in detail in the next course, IT automation. So how do you keep track of your troubleshooting? A common industry standard is to use some sort of ticketing or bug system. This is where users can request help on an issue and then you can track your troubleshooting work through the ticketing system. This helps you organize and prioritize issues and document troubleshooting steps. Throughout this course, we'll introduce types of services that a sysadmin needs to maintain and what responsibilities they have in an organization. We'll also share some best practices for troubleshooting when it comes to systems administration. When you work as an IT support specialist, systems administration can become part of your job. so it helps to think about all aspects of managing an IT infrastructure in an organization. The more prepared you are, the better. Let's take a bit of a dark turn and talk about disasters. Like it or not, something at some point will start working, no matter how much planning you do. This happens in both small and large companies. It's an equal opportunity problem. You can't account for everything, but you can be prepared to recover from it. How? It's super important to make sure that your company's data is routinely backed up somewhere, preferably far away from its current location. What if a tornado struck your building and your backups got swept away with it? You wouldn't have a building to work in, let alone be able to recover your data and get people up and running again. Later in this course, we'll talk more about what methods you can use to back up your organization's data and to recover from a disaster. We'll try to keep things a little lighter in the meantime. So far, you've learned a lot about the roles and responsibilities of a sysadmin. Some of it may seem like a lot of work. Some might even seem scary. Being responsible for keeping data available isn't easy, but it's a rewarding role in IT. And you're already building your SA or sysadmin skill set by learning the fundamentals of IT support. Next up, we got a quiz for you. Then in the next module, we'll discuss the technical details of the infrastructure services used in IT. See you there.
My name is Dion Paul, and I am an operations specialist with the GTech risk team. GTech stands for Google Technical Services. I wasn't always too familiar with IT, but one misconception is that you can know enough. And what I found out is that you can never know enough. There's never a threshold of learning. Things are always going to be changing, especially in IT, so it is very important to keep learning, keeping abreast of the latest technologies, wherever it leads me to. I'm never going to stop learning, and I'm always going to be open to learning new things and applying those in different ways. My most memorable career moment was actually getting to meet the former First Lady Michelle Obama during a work trip. I was selected to participate in a project at the White House based on the work that my team was doing, and we were able to not only engage her in a virtual reality shoot, but I also was tasked with ensuring that all the equipment was working, placing it directly in front of her, meeting her, and the content was going to be rolled out to millions of kids around the world. Being able to operate a camera with the First Lady right in front of me, which is a moment I won't ever forget. Success to me is a journey, and I define it as just peace. Just being at peace with your work career, being at peace with your family, whatever that means to you, whatever that personally means. I like being able to have some quiet time on the weekends outside of work to spend with my family and stuff. At work is being involved in projects that you're passionate about and feel like you're contributing to just a greater thing. But to me, success is a journey, and to me it's defined as just being at peace with whatever you're working at.
Welcome back. In the last module, we learned that system administrators have lots of responsibilities, like maintaining infrastructure services. IT infrastructure services are what allow an organization to function. These include connecting to the internet, managing networks by setting up the network hardware, connecting computers to an internal network, etc. In this lesson, we're going to learn about the common IT infrastructure services out there and what you need to know to start integrating them into an organization. We'll also dig deeper into each infrastructure service individually. We will focus more on the physical infrastructure services like servers, along with network infrastructure services that keep your company connected to the internet. In short, we'll be servicing all your infrastructure services needs. There are lots of IT infrastructure services that keep a company running. In a smaller company, a single person could be responsible for all these services. In larger companies, teams of sysadmins might manage just one service. In this course, we're going to discuss what you'll need to set up these services as the sole IT person in a company. We'll also give you an overview of some of the cloud services that you can utilize if you wanted another company to run your services. Reminder, as we mentioned before, cloud services are services that are accessed through the internet, like Gmail. We can access our Gmail accounts from any computing device as long as we're connected to the internet. By the end of this module, you should be well versed in what services you'll need to have a functioning IT infrastructure for your company. There are lots of types of IT infrastructure services out there. We'll start by giving you a high-level overview of them in this lesson. Then we'll dive into the nitty-gritty details on how you configure and maintain these services in later lessons. Sounds good? Let's get started. We talked about physical infrastructure components of an IT environment in an earlier lesson. Remember that you can set up different servers to run your services on, like a server to run your file storage service. You can buy or rent hardware for these servers and set up and store them either on-site or at another location. Essentially, you manage these servers end-to-end. There's another option. If you don't want to be responsible for managing the hardware tasks and updating your server operating systems with security patches and updates, you can use the cloud alternative to maintain your own infrastructure, which is called Infrastructure as a Service, or IaaS. IaaS providers give you pre-configured virtual machines that you can use just as if you had a physical server. Some popular IaaS providers are Amazon Web Services and their Elastic Compute Cloud, or EC2 instances, Linode, which rents out virtual servers, Windows Azure, and Google Compute Engine, which you've been using throughout this course. You can read more about the different IaaS providers in the supplemental reading right after this video. Your company's internal network isn't going to be like your network at home. You're going to have multiple computers that need to be on a certain subnet. You have to assign them IP addresses statically or using DHCP. The networking hardware has to be set up. Wireless internet will probably need to be available. DNS needs to be working, etc. If your company is large, networking is usually taken care of by a dedicated team. But in smaller companies, you'll probably be responsible for setting up the network. Network can be integrated in an IaaS provider, but in recent years, it's also been branched off into its own cloud service, Networking as a Service, or NaaS. NaaS allows companies to offshore their networking services so that they don't have to deal with the expensive networking hardware. Companies also won't have to set up their own network security, manage their own routing, set up a WAN, and private intranets, and so on. For more about NaaS providers, check out the supplemental reading. Let's talk about the software that your company might want to use. Do you need to type out Word documents, use an email client, communicate with other people, use operating systems, process spreadsheets, or have any other software needed to run a business? I bet yes. The right software has to be available to your company's users. We've already discussed how to install and maintain software and machines. You have to deal with things like licenses, security, updates, and maintenance for each machine. The cloud alternative to maintaining your own software is known as Software as a Service, or SaaS. Instead of installing a word processor on every machine, you can use Microsoft Office 365 or Google's G Suite. These are both services that you can purchase that allow you to edit Word documents, process spreadsheets, make presentations, and more, all from a web browser. You can check out the next supplemental reading for more about SaaS providers. Some companies have a product built around a software application. In this case, there are some things that software developers need to be able to code, build, and ship their software. First, specific applications have to be installed for their programming development environment. Then, depending on the product, they might need a database to store information. Finally, if they're serving web content like a website, they'll need to publish their product on the internet. If you're building this entire pipeline yourself, you may need to set up a database and a web server. The programming development environment will also have to be installed on every machine that needs it. If you want an all-in-one solution to building and deploying a web application, you can use something called Platform as a Service, or PaaS. This includes an entire platform that allows you to build code, store information in a database, and serve your application from a single platform. Popular options for PaaS are Heroku, Windows Azure, and Google App Engine. As you might have guessed, you can read more about PAS providers in the supplemental reading. The last IT infrastructure service we'll discuss is the management of users, access, and authorization. A directory service centralizes your organization's users and computers in one location so that you can add, update, and remove users and computers. Some popular directory services that you can set up are Windows Active Directory, OpenLDAP, and we'll dive a little deeper into both of these later on in this course. Directory services can also be deployed in the cloud using Directory as a Service or DaaS providers. Guess where you can read more about DaaS providers? That's right, in the supplemental reading. There you have it. There's a general overview of the most common IT infrastructure services you'll encounter when handling system administration tasks. While cloud services are a great option, it's super important that you understand how a service works and how to maintain before you employ the help of a cloud service. Even though cloud services are widely used in the industry and have a lot of pros, there are also some cons. These include recurring cost and the need to depend on the provider's service. We're going to teach you about the technical details and the implementation of these common IT infrastructure services. We'll cover everything from setting up your own server and figuring out which applications you need to be productive to how to set up multiple users and get your network services in order. By the end of this course, you have the foundational knowledge required to set up the IT infrastructure for a small organization.
I grew up in a small town in the desert, and there wasn't really much to do except read, play with computers, and study. And this is where I really learned to love technology, to understand how this computer worked, how it did what it did, and how I could make it do something different. And when I went to college, I began to study the Unix operating system. And I learned just enough to get an internship at the local ISP. And this was quite alarming for me because the first day of my internship, I walked in and they said, "Great, we're so happy you're here. You know Unix, right?" "Yes." "Here's a Radius server. We want you to set it up. It needs to be done by the end of the week." And I said, "How exciting. I get to do something that will have an impact on our users, and I will get to learn something." There was just one problem. I didn't know what Radius was. So this was going to be quite a difficult challenge for me. So I had to read the manuals, the man pages, and I had to scour the library for books. And it took me about 3 days to learn what Radius was and how to set it up. But in the end, I knew more about it than anyone else at the ISP. And that expertise really, I think, drove me to become an expert in more areas. It gave me a lot of confidence that I could do that work, and it was actually really invigorating. And so I ended up as a Unix sysadmin and sort of went from there.
When you want to set up a server, you essentially install a service or application on that server, like a file storage service. Then that server will provide those services to the machines that request it. Maybe you thought you'd install services on a user operating system like Windows 10. While that's an option, typically in an organization, you'll want to install your services on a server operating system. Server operating systems are regular operating systems that are optimized for server functionality. This includes functions like allowing more network connections and more RAM capacity. Most operating systems have versions specifically made for servers. In Windows, you have Windows Server. In Linux, many distributions come with server counterparts like Ubuntu Server, which is optimized for server use. Mac OS is also available in Mac OS Server. Server operating systems are usually more secure and come with additional services already built in, so you don't have to set up these services separately. You can read more about the different server operating systems in the next supplemental reading. For now, just keep in mind that when you install services on a server, you should be sure to use a dedicated server operating system. We discussed virtual machines in the last course and covered how to set up a virtual machine on a personal computer. In this lesson, we're going to talk about why virtualization can be an important part of infrastructure services and systems administration. There are two ways you can run your services, either on dedicated hardware or on a virtualized instance on a server. When you virtualize a server, you're putting lots of virtual instances on one server. Each instance contains a service. There are a bunch of pros and cons to running your services on either of these platforms. Here's the rundown. Performance. A service running on a dedicated hardware will have better performance than service running in a virtualized environment. This is because you only have one service using one machine, as opposed to many services using one machine. Cost. Server hardware can be pretty expensive. If you put a service on one piece of dedicated hardware and have to do that for 9 other services, it starts to add up. One of the huge benefits to virtualizing your servers is that you can have 10 services running on 10 different virtual instances, all on one physical server. Here's another way to think about this. In a typical server, if you only have one service running, it's probably only taking up 10 to 20% of your CPU utilization. The rest of the hardware isn't being utilized. You could add plenty more services to the physical server and still have a good threshold for resource utilization. It's cheaper to run several services on one machine than it is to run many services on multiple machines. Maintenance. Servers require hardware maintenance and routine operating system updates. Sometimes you need to take the service offline to do that maintenance. With virtualized servers, you can quickly stop your service or migrate them to another physical server, then take as much time as you need for maintenance. Virtualized servers make server maintenance much easier to do. Points of failure. When you put a service on one physical machine and that machine has issues, you're entering a world of trouble. With virtualized servers, you can easily move services off a physical machine and spin up the same service on a different machine as a backup. You could also do this with a physical server, but that could become costly if you account for multiple servers. Pro tip, you can prevent a single point of failure on a physical machine if you have a redundant servers set up, meaning you have duplicate servers as a backup. You'll learn about backups in an upcoming module. As you can see, there are lots of benefits to using virtualized servers. Just make sure to weigh the pros and cons of virtualizing your servers and using dedicated server hardware. That way, you can make the right choice for your company. Another important part of physical infrastructure services is the ability to connect to your infrastructure from anywhere in the world. We talked about remote access in an earlier course, and we've been using it all throughout this program to connect to our lab machines. In this lesson, we're going to discuss what's needed to set up for remote access for a small organization. As a systems administrator or as anyone in IT support, you'll want to be able to remotely access another server or user's machine so that you can troubleshoot an issue or do maintenance from wherever you may be. In Linux, the most popular remote access tool is OpenSSH. We've already learned how to SSH into a remote computer in the last course, and we talked a bit about what's needed to set up SSH, but we'll quickly show you how to do this. To SSH into another machine, you need to install an SSH client on the machine you're connecting from. Then install an SSH server on the machine you're connecting to. To learn more about OpenSSH, you can check out the next supplementary reading. But let's keep rocking and rolling with how to install the OpenSSH client on a machine. It's super easy.
What you're going to do is I'm going to go to my client machine and simply run this command, sudo apt-get install OpenSSH client. And going downloading the package. Perfect. So it looks like my client has been installed. Next, you need to install the OpenSSH server on the machine you want to access. Remember, the SSH server is just a process that listens for incoming SSH connections. So let's go to the server and install the OpenSSH server. So I'm going to do sudo apt-get install OpenSSH server. Perfect. So it looks like my server is up and running. So let's go back to the client and do a test. I do SSH, enter my server IP address with my username. So ask for my password, which is a good thing. Perfect. So as you can see, I'm connected to my server, and one true way to test this is if I go into my desktop of my server, and let me create a folder. Now if I go back to my server, which is on this window, I list the files, you can see the folder test, and that's it. Now you're able to SSH into a machine from another machine. Not too complicated, right? Windows has similar tools that you can use. A popular tool to access the CLI remotely is WinRM or PART-2. RDP is also popular if you want to access the GUI remotely. We've already discussed how to connect to a machine using PART-2 in the last course. Just remember to install an SSH server on the machine you want to connect to. We also already discussed how to set up RDP in the last course. Feel free to review those lessons as a refresher. You can read more about the Windows remote access tools in the next reading. The takeaway here is that when you manage IT infrastructure, you can utilize tools like remote access to work on your physical infrastructure. You'll need to do a little bit of setup beforehand, like installing SSH client, SSH servers, and allowing remote desktop connections, etc. But it'll be worth it in the long run. Next up, we'll tackle network service. See you there.